All right. Let us begin. If we just do a quick recap on what we did last time. سوينا mesh analysis اللي هو Maxwell's mesh analysis. What do? We take the currents clockwise. زين. After you redraw the circuit, you take the currents clockwise. بتاخذون first you'll assume the current clockwise, بعدين you will identify the polarities. Remember, when current is flowing through something, through a resistor specifically or through a component, بيكون يروح من البلس لين الماينس، فبتحطون plus minus, and it is always based on the assumption you make. When الassumption في البداية, when you assume it, it's fine, it might be correct, it might be wrong, عادي، لأن بعدين in the result, if it's negative, it will be clarified later on. So the assumption at the beginning, and you will identify, then you will do KVL for each loop. Basically, you're gonna choose the current, do the KVL. What was KVL? Kirchhoff's voltage law. So you will see the voltage at each point, and then the voltage here plus voltage here plus voltage here plus كامل لين هني لازم يساوي 0. So when it's going from minus to plus, all right, it is going to be positive. If it's going from plus to minus, it is going to be negative. And that was the whole idea. We will find the first one for the first loop, and then the second one for the second loop, yani for IA and IB. Remember that here you are going to assume if it's a voltage drop or if it's a voltage gain, depending on your current assumption direction. But when you're doing it for loop A, you're going to assume that only current A is existing here. بعدين you're going to look at it from the point of view of current B. So the plus and minus is going to switch. The plus is going to be at the bottom and the minus is going to be at the top, لأن the current is flowing in that direction for the purple current, which is IB. Once you find that out, you're going to come out with a equation, two equations. You will solve the simultaneous equations. You can use mod 5.1 on the calculator to find it very quickly. And then you will be getting your values. Once you get your values, we are going to do the voltage. We are going to find the current, and we're going to do our final circuit in the way it is supposed to be. Now, let us do one more example for mesh, right? Before we move on to nodal. So let's do this question now. Week 6, part B. In this given circuit, زين خلينا نرد نرسم السيركت. عندنا هني we have a voltage source, then we have a resistor over here, and then we have a resistor also over here in the middle. Oops. And then we have a voltage source again here. We have another resistor over here. Then we have another voltage source over here as well. And then we will close the circuit like that. And then, so we know that this is plus minus. Oops, خلينا بالأسود هنا for now. This is plus minus a voltage. V1 is given to be 20 volts. We have plus minus over here. V3 is given to be 6 volts. This is 20 volts, 6 volts, and then we have V2, which is V2 is 15 volts. All right. And then a resistor R1 is 275 ohms. And then a resistor 2, which is 350 ohms. And the resistor 3, which is 150 ohms. So now we have our circuits. We are going to assume our current direction. It's already also given in the question to assume it in this way. This is IA, and we have IB. B. Okay, this is the assumptions we will first have. First, based on loop 1. So we're just going to look at loop IA. Obviously, all of the pluses are here for voltage. It's already given. So this is plus, plus, plus. And this is minus, minus, minus. We are going to assume this as our ground. This is going to be our ground. زين. Ground معناته this whole bottom part is equal to 0. All right. This is our ground. هني for polarity, this is going to be plus and minus. Here, polarity is going to be plus and minus in this way when we are looking at it from loop A. Okay, it's going to be plus minus like this. And then we have this, which is plus and minus like this based on IB because this isn't being affected by IA. So we have determined now the polarity of all of them. Now we just have to apply the KVL, Kirchhoff's voltage rule. Okay. So for the first loop, and then before that, here this is going to be plus and minus in the case of loop B. Just I'm going to draw it from now, عشان there's no confusion. If we are going to look at loop IB, the plus and minus is going to be in the opposite direction. Now, let us start analysis for loop A. So loop IA. Okay, this is going to be our first. This is going to be our first loop that we will do the analysis for. Let's start from the voltage source. It is 20 volts. So it's going to be 20 volts plus positive 20 volts يعني. Then it's going from minus to plus. If you look at the current, it's going like this. Then this is the current direction from IA. Okay, so it's going to be plus 20 volts minus, when we're looking at this resistor, because it is a voltage drop going from plus to minus, minus 275 times IA. Okay. Minus, again, this is a voltage drop in terms of IA. So this is 350 volts, 350 times IA minus IB. ليش IB؟ لأن IB is in the opposite direction. So minus IB. And then we have our last voltage here. We are going from plus to minus. So this is going to be a voltage drop. The voltage here is against the current. So it's going to be negative 6 volts. And all of this is equal to 0. All right. We can simplify this now. If we simplify this, 20 minus 6 is 14 volts. Let's open up this. So it's minus 275 IA minus 350 IA plus 350 IB. So this is IA. I'm just distributing IA plus 350 IB. Again, another way you can look at this is in IA, it is a voltage drop. If we're looking at the left side now, we're looking at the left loop. This is a voltage drop in terms of IA, but IB is going upwards. So it is going to be a voltage gain in terms of IB, from the perspective of IB. That is why it is going to be positive here. This is another way you can look at it. And now we can simplify. Let's group everything up. So the 14 volt will take to the other side. Let me get my calculator. So minus 275 minus 350 is equal to minus 625 IA plus 350 IB is equal to 14 volts is plus here. On the other side, it will become minus 14 volts. And this is our first equation. This is equation 1. Okay, from loop IA, the first loop. Now that we finished the first loop, we're going to look at this again, but from the perspective of the second loop from IB. All right. So if I bring this down here, so we can just look at it from this side. Again, now we are going to look at it from loop IB. So we don't care about IA. We are not going to look at it from IA's perspective. So we're not looking at this current at all. And then we're not looking at this. We are looking at IB that is going in this direction, or that we assumed is going in that direction. Again, we can start from this voltage source if you want. So starting from this voltage source, plus minus 15 volt. This is going from plus to minus. So this is a voltage drop. So this is going to be minus 15 volts. All right, because we are going from plus to minus, we'll come here. We are going to this voltage source now. So it's minus plus. So it's minus plus. So it's gaining. So this is going to be plus 6 volts. Then we're going to go to this resistor. So now we're looking at it from the right side. So the plus and the minus. So this is going to be a voltage drop for IB. All right. So it's going to be minus 350 IB minus IA, because they are in opposite directions. IA. And then we're going to go to the last current, last resistor. The current is dropping. It's a voltage drop, obviously. So it's going to be minus 150 IB, which is equal to 0. Tamam? So if we simplify this, minus 15 plus 6 is minus 9 volts. Let's distribute this. So minus 350 IB plus 350 IA. Again, you can look at this directly. And if you want, you can write this directly instead of writing it in brackets. ليش؟ لأن now we're looking at it from the right-hand side. It is a voltage drop in terms of IB, which is the purple, and it's going as against it. So it's going from plus to minus. But IA is positive because it's going from plus to minus. So from minus to plus, sorry, and from the perspective of IB. Tamam? Then we're going to just simplify this also. Minus 150 IB. IB, and this is going to be equal to 0. All right. And then we can further simplify this. We will take the 9 volts to the other side. بيبقى لنا هني minus 350 minus 150. So minus 350 minus 150 is equal to minus 500, I believe. Yes, minus 500. IB plus 350 IA is equal to what is what the minus 9 volts is on the left. We took it to the right, so it became plus 9 volts. All right. I'm going to just reorder this. So IA is first and IB is first. I'm not going to change anything. So it's just going to be 350 IA minus 500 IB is equal to 9 volts. That's all I'm going to do. So IA is here and IB is here. And this is our second equation. Tamam? So now we have our two equations. We have our equation 1, we have our equation 2, we have our two unknowns, which are the current, and now we can directly just solve for the current. لو كانت دائرتين الكرنت داشين على نفس النود شلون يصيرون الأقواس في المعادلات؟ That will never be the case as long as you're assuming clockwise to always be the direction, unless you're going to have it on top. If they are in the same direction, do this analysis like I did earlier. زين اللي هو make sure you look at the current direction زين and you will know if these currents are together or against each other. The reason I put minus هني لأن ال arrows are opposite in direction. بس إذا مثلا زين اخترنا IB to be in the opposite direction, يعني not clockwise, anti-clockwise, and they are in the same direction, this will become plus because they are supporting each other. The easier way to always identify this is if you're looking at loop B in this case, نعرف هني plus وهني minus. So we know that this is going to be a drop. If this is also causing a drop, it is going to be negative. In this case, this is causing a gain because it's going from minus to plus, so it's going to be a positive. This is how you will be able to identify it. All right. فإذا كملنا الحين عندنا our two equations, which is this is the first one, and this is our second equation. Now we can solve this using simultaneous equations directly from the calculator. We can just use mode 5.1. So mode 5.1, all right, using mode 5.1, we're gonna put minus 625, 350, minus 14, 350, minus 500, and 9. We will get x first, x, which is equal to IA. Then this is the first value we have, it's on the left. So this is going to be equal to 0.02026 amperes, and then we have y, which is equal to IB. It is equal to minus 0. Or minus, I'm getting it in the calculator as 3.816 times 10 to the minus 3 ampere. Okay? يعني 0.003816. That's what that means. Ampere. تمام? يعني what we can also do is convert them into milliamps. If we want to convert this into milliamps, we just multiply it by 10 to the power of 3 times 10 to the power of 3. This is just to convert it to milliamps. This is going to be equal to any fog. It's going to be 1, 2, 3. So it's going to be 20.26 milliamps. And the bottom one is just going to be negative 3.82 milliamps. All right, just multiplying by 10 to the power of 3. You guys should already know how to do this conversion. الحين حصلنا احنا الكرنتس. Okay, that was the whole question. The loop currents are already assumed in the direction, so apply the mesh analysis to answer the following questions. Yes, I did not show you the questions last time. Let us look at the questions now so you get an idea on what they wanted us to find. Where were the questions? These were the questions that they were asking. So they want the loop current IA and the loop current IB. And then IA, we already found it to be 20.26, and they wanted it in milliamps as well. They wanted it in milliamps, so we multiplied by 10 to the power 3 to find it in milliamps. Same thing, they wanted current B in milliamps, so we converted it already to milliamps because we multiplied by 10 to the power 3. We found the loop current IA and IB, and you can notice it says the sign of the current is negative. If the sign is negative, then it is indicated that IB is actually flowing in the anti-clockwise direction. And here we already found IB to be negative. So if I just copy paste this diagram again, and we put the correct directions now, this is what it is going to look like. Then, but we know that IA is in the correct direction. Then, and it's equal to 20.26 milliamps. So this is 20.26 milliampere in this direction. And IB, we found out that it is negative. So it is 3.82 milliamp in the opposite direction. It was not clockwise, it's anti-clockwise. It's in the opposite direction than the given one. So we know that the flow of current is going to be in the opposite direction. So the current is actually flowing in this way. So now we know that the polarity we assumed was not the correct polarity as well. Then the polarity here is, where is it here? The polarity here is in the opposite direction. Now we assumed it wrong, but that's fine. That is the whole idea of making an assumption. The negative sign is only going to change the direction. And now also in the middle, we know that this is the correct polarity of the middle one because there's these two currents adding up to each other. And then, so because these two currents are in the same direction, let's call this current over here then let's call this current over here, okay, I3. I3 is going to be equal to IA plus IB. Why is it added? Because now that we found the directions, and then we can directly just add the IB and IA because they're going in the same direction. Because we already have found the direction. You can either do it this way or do it based on the assumed direction and put minus but keep the sign, okay? Which we did last time. So in this way, if you can already see that the currents are both in the same direction, you know, you just have to add up these two to find your actual total current. So I3 is going to be equal to actually, let's call it I2 because the resistor in the middle is I2 so that there's no confusion. Let's call this I2 and then I2 and I2. So we know that this is going to be equal to IA is 20.26 milliamp plus IB is 3.82 milliamp. So I2 is going to be equal to, just put that in the calculator, 20.26 plus 3.82, it is equal to 24.07 milliamp. All right, this is our current I2, which is the current in the very middle. So we found the current going through everything now. فالحين السؤال يقول find the current IR1 also and IR2 and IR3. Remember that the current flowing through IR1 is flowing through this resistor. زين. Which current is it? It's the orange current, so it's equal to IA. So this is IR1, and then this is IR2. This current over here is IR2, and this is IR3. Actually, let's use a different color. Let's use red. This is IR3. Okay, this is IR3. For the current that is flowing through IR1, the blue one, all right, IR1 is equal to IA. Then it's the only current flowing through it. And which is equal to basically 20.26 milliamps. All right. The current going through I2, R2, the green one, is the current I2, which we already have determined is the addition of IA plus IB. So we know that R2 is equal to I2, which is the current we found, which is equal to 24.07 milliamps. And the last one, current IR3 is equal to, if we look at IR3, it is the one with the purple current only going through it, which is IB, and it is equal to 3.82 milliamps. All right, and we have solved the entire question using Maxwell analysis. Any question about Maxwell? Any question? Is it clear, the middle current? This is the most important thing, understanding the middle current. Is this clear? Is this point clear? I also explained it a lot last time, but I want to make sure that all of you understand this over here. Does anyone have any questions about the middle current? How we got it? So here we are doing it based on the directions that we can see with our eyes. Last time when I did it, I put IA minus IB, but I was assuming the direction to be negative. Why? Because I was assuming the direction initially of IB to be going to the right. All right? At this node. So when I was assuming this going to the right, IA is equal to IB plus IR. So IR is equal to IA minus IB. But here the assumption was to the right. It was not to the left. We did not fix our assumption. So we kept the negative value inside our solving, inside the equation. All right. In this case, now I already have changed the direction. I have already analyzed it and changed the direction. So I know this is the correct direction. Yani if we look at this node now, if we look at just this node over here, oops. If we look at just this node over here separately, we don't need all these numbers. We just need to look at I2. All right. So this is I2 or IB that is going this way. And this is IA that is going this way. So we're analyzing this node right now. We're looking at this node, all right? So at this node, we can notice that IA is going in, IB is going in, and I2 is going out. So this is what KCL is all about. KCL. It is Kirchhoff's current law. And what does that say? It says that all the sum of currents entering a node has to be equal to the sum of current exiting a node. Another way of saying this is the sum of current at a node should be equal to 0. What does this mean? Let us look at this example عشان نشرح ال KCL. So IA, I2, and IB. All right. IA, if we will take the direction going into the node as positive, and the direction of going outside of the node as negative. زين. So IA will be positive. So IA is positive. IB is positive. And IC or I2 is negative. Why? Because this is entering node. This is also entering node. And this is exiting the node. This is one way of looking at it. So anything that is entering plus anything that is exiting is going to be equal to 0. This is if we are considering their signs. So here, IA is positive. So this equation will become IA plus IB minus I2 is equal to 0. بما معناه IA plus IB is equal to I2. زين? This is what I mean. So IA and IB are the ones entering a node, and I2 is the one exiting the node. All right? This is what Kirchhoff's current law basically is. Anything entering has to be equal to anything exiting, or if we are considering the signs, we should just say everything here should eventually equate to 0. This Kirchhoff's current law is how we are going to do the analysis for nodal now. So is it clear? Is KCL clear? Is everything about this clear so far? Do we have any questions about KCL or generally mesh and Maxwell before we start solving for nodal? Let us, before moving on, before we move on, let us just let me make a new page because we are going into nodal now. EE week 7. All right. And I'm going to copy paste this over there. And this over here has nothing to do with mesh. It is a nodal theory, which is KCL. So it's a new theory. This is the KCL. All right. So let us take an example here. إذا عندنا a circuit, a basic circuit. Some simple circuit here with a resistor in the middle as well. And let's just say this is how it is. So if we're looking at this node, okay, we know that this is plus minus. If we look at this node, what do they mean by node? They mean the voltage at this node, okay? V at this node. Then, if I remember that this whole thing has the same voltage, and this whole thing has the same voltage. We'll call this V1, we'll call this V2, and then again, this whole thing over here, it's gonna have the same voltage. We'll call this V0 or ground, which is equal to 0. And then, so we're going to look at V2 as our node. What defines a node? A node is a point that has more than 2 circuits connected to it. So yani we have more than 1 point connected to it. Here, this corner is not a node. This is just a normal wire. Here, this is not a node. The bottom here is another node. The bottom here, this is another node. All right. But at this node, we are already assuming that this is our ground. So we know that the voltage here is 0. So let us apply KCL for this node. And then let's put random numbers here. Let's put this as 10 volts. Let's put this as 10 ohms, 5 ohms, and 20 ohms. Okay? If we're looking at node V2, node V2, we're going to apply KCL. What does KCL mean? We're going to look at current. زين فعندنا احنا الكرنت الحين going in from here. All right, current is leaving from this, it's going in like that, and then we're going to assume that it is separating here into two ways. So it is going one in this direction, all right, and another one in that direction. Okay, so we have two currents. So if I'm just going to look at this node now, if I just make it larger, this is the node that we have. This is the node. We have a current entering. Okay, we have a current exiting from this side, and we have a current exiting from this side. Let's just, for simplicity, call this I1, and then I1, and this will be called I2, and this will be called I3. Okay, I3. So we have three different currents. Tamam? Now I1, I2, and I3. So what does Kirchhoff's law say? That I1 is the one entering. I1 has to be equal to I2. It's green. I2 plus I3. صح ولا لا? Anything entering has to be equal to everything that is exiting a node in terms of current. This is the KCL law. And we also know from V, which is equal to IR, that I is equal to V divided by R. And then this is the case. So for the case of I1, it's going to be V1 over R1, or VR1 over R1 to be more specific. صح ولا لا؟ هني our blue is I1. Okay. V2 is an unknown voltage. We don't know what it is. V0, we know what it is. So if we want to apply V equal IR, we are applying it to a resistor. So it has to be the voltage of the resistor. So VR1, we also know that VR1, if you remember from before, VR1 is equal to, now if we put the polarities here, this is plus, minus, this is plus, minus, and this is plus, minus. Right? And this is obviously plus, minus. Tamam? So if we're looking at this, the polarity here is plus, minus. So we know that I1 is going through this 10 ohm resistor. All right, we have a resistance of, this is where the blue one, and this is I1 basically. All of this is for I1. So let me write it in blue. So I1 is equal to VR1 over R1. So in other words, what is VR1 also equal to? VR1 is a voltage, it's a voltage drop across the resistor. So it's going to be equal to the voltage of the plus minus the voltage of the minus. So it's V1 minus V2. So this is equal to V1 minus V2. All right? This is what we were explaining last session. So V1 over minus V2 over R1. So this is also equal to I1. Now we are going to plug this into this equation here, because this is equal to I1. And we will do the exact same thing for I2 and I3. This is exactly what I meant by this is the same as KVL, but for current. So this is KCL. It is the same idea as we did for mesh, but instead of looking at mesh now, we're looking at voltage. We're looking at nodes. We're not looking at current. All right, we're using current to find the node. So if we're looking at I2 now, the same exact concept. It is equal to VR2 over R2, and then which is equal to R1 over here is the 10 ohm resistor. So I'm just going to write 10. All right, and I'm going to change the voltage from 10 volts to 7 volts, just so there's no confusion between the numbers. And then 7 volts. So V1 minus V2 over 10 is going to be plugged into that. If we simplify this even more, this is going to be equal to V1. We already know that V1 is going to be equal to 7 volts. Why? Because this is the plus part and the minus part here is 0. So we know that 7 minus 0 is going to be equal to this 7 volt over here. This is going to be 7 minus V2 that we don't have over 7 minus V2 over 10. This is what we will substitute now inside of I1. Okay, this is our I1. Tamam? Again, the same thing we will do for I2. It's VR2 over R2. VR2, if we look at the circuit here, where is VR2? This is, again, this is VR1. This is VR2. Yeah, this is what I called VR2. Over here, the voltage drop, and this is VR3, the purple one. So we're looking at VR2 now. VR2 is equal to V2, which is at the plus side, minus V0, which is 0. So it is V2 minus V0. And we know that V0 is equal to 0. All over R2, which is R2 in this case is 20 ohms. Tamam? So if we simplify this even more, the V2, which is just by itself at the top, is over 20. That is what I2 is equal to. فالحين I2 I2 is equal to this equation. So we will substitute this in the place of I2. Lastly, we have I3 is equal to VR3 over R3. So it's equal to, what is R3? Again, R3 is V2 minus the V0. This is where the plus is. All right, if you look at it here, we have the plus over here. All right, the minus over here. So V2 is at the top, the red line is at the top, so it's V2 minus the orange line, which is at the bottom, which is V0. So that's what VR3 is equal to. So VR3 is equal to V2 minus V0. V0 is equal to 0 because it's the ground, divided by R3, which is given to be 5 ohms. And this is going to be equal to V2 divided by 5. This is going to be our I3. All right. And we will substitute this. We will substitute this into our I3 in the equation above. So now let's rewrite this equation using the substitutions. So remember we had this equation I1, which is 7 minus V2 over 10. So 7 minus V2 over 10. This was our I1. And then it is equal to, so it is equal to I2, which is V2 over 20. So it's V2 over 20. And then we have plus I3, plus I3, plus what is I3? Wait a second. Plus I3. So I2 is in green. Let me keep this in green, over 20. All right. Reminder that this is I1, this is I2. And now we are going to find I3, which is V2 over 5. Okay, over 5. And this is how we solve using nodal analysis. This is exactly it. So now instead of finding current, we are trying to find voltage. This is when you will use nodal over or instead of mesh. When in general, when you're analyzing, obviously in the exam, they will tell you directly use mesh to do the analysis or use nodal. You can use either or in each situation, but it depends on what you are trying to target. The idea is you're trying to find something specific. If you're trying to find voltage, you're using nodal. If you're trying to find current, you're going to be using mesh analysis. All right. If you notice here, now we only have one unknown. So this is 7 minus V2 over 10 is equal to V2 over 20 plus V2 over 5. زين. Our only unknown over here is V2. This is the only thing we're trying to find. V2, V2, and V2. تمام? Now we can solve this equation to find V2. So first thing I'm going to do is I'm going to multiply everything by 20 to cancel out all the denominators. That's how I usually solve these. So I'll multiply by 20 here, and I will multiply by 20 here. Because anything you do on the left, you do on the right. So it's going to be 20 over 10. Then 7 minus V2 is equal to 20 over 20. Then if we distribute this 20 is going to be distributed here and here. Then, so 20 over 20 times V2 plus 20 over 5 times V1. V2 again, sorry. Then, الحين 20 over 10, this is going to be 2 times 7 minus V2 is equal to V2 plus 20 over 5 is 4 V2. Distribute 14 minus 2V2 is equal to V2 plus 4V2. We will group up all the V2s together. And then we're going to just group up the V2s now together. This is V2, V2, V2. This is what we're trying to get. So V2, we will take to one side. So 14 is equal to, we have V2 plus 4V2 minus 2V2 becomes plus 2V2. So 14 is equal to 1 plus 4 plus 2, which is 7 V2. Therefore, V2 is equal to 14 over 7, which is 2 volts. And this is how you will find it. All right. Easy. So you can see the reason nodal is a bit annoying is you deal with fractions more. طبعا تقدرون تحلون الفراكشنز بالطريقة اللي انتم مرتاحين فيها. This is how I usually do it. I look at the largest denominator at the bottom and multiply everything with that large denominator to get rid of it. But you guys can use any different method you want to solve this. على راحتكم. You can do cross multiplication, for example. Find the common denominator here, do the cross multiplication. Up to you, whichever is easier to solve. The algebra part you guys should already be familiar with. And we just need to find voltage 2. And now we did. Now that we found V2, we can also find the voltage across any resistor. So VR1, we know that VR1 is equal to V1 minus V2. So we just plug in 2, it's going to be 7 minus 2, so VR1 is 5. And we know that VR2 is equal to VR3 because they are both V2 minus 0. So they're also both going to be the same voltage in value. They're both going to be equal to 2. All right. This is how you would usually solve it. Any questions? Let's solve an actual question instead of one I just made from my head. Any questions about this before I solve an actual question? Week 7. زين. So this is what KCL is. يعني earlier we were using KVL for mesh. Here we are using KVL for the loops. We are putting voltages and doing IR, 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 and voltages. Here we are going to be doing case nodal. So we're going to be putting I instead of, so we're going to be dealing with current. I1 is equal to I2 plus I3 instead of doing voltages. So we can find voltages. So in mesh, we are trying to find current. So we are using voltage. In nodal, we are trying to find voltage. So we are using current. All right. Now, let's solve this question. Week 7. As you can see, they gave us a very simple circuit as they usually do. Then, I'm pretty sure at this level, they're not going to give you something way too complicated. I've seen the past exam very slightly, and it looked, didn't look too scary بصراحة. If we get the chance اليوم inshallah, why not? We'll try to take a look at it together and try to just solve everything very quickly and see how it will be. But first, let us make sure that we understand all the concepts that we need to understand for the exam. فعندنا الحين هني 3 resistors. two voltage sources. All right, this is what it looks like. Plus, minus, and then if you notice one thing here, it is already defining the current direction in the drawing. It's telling you that the currents are going in a specific direction, so you can assume the same direction just to make it easier for yourself, or you can make the assumption in any way you want. It really doesn't matter. Even if you're completely wrong in every assumption, عادي, when you get a negative value, just know that you assume the opposite direction. That's it. Now, given voltage 1 is 20, voltage source 1 is 20 volts, so this is 20 volts. Voltage source 2 is 16 volts. We know that these polarities are fixed. This is plus, plus, minus, minus. Okay. Make sure you're always, when you're drawing any circuit now, الحين تفهمون شو معناته polarity. Make sure you're always drawing your polarities after assuming your directions for current. And for voltage sources, instantly just write your polarity to make sure you know where's the plus and where's the minus. They told us to assume that current is going into this direction for the first one. And for the second one, they told us to assume current is going into this direction. And for the middle one, they told us to assume that current is going into this direction. What did we use last time? Let's use green. Okay. تمام. This means يعني هني is also going to be blue. زين. Obviously. And this is also going to mean that here it is going to be also purple. All right. Only in the middle they're grouping up and then they're splitting back up again. Let's name these currents I1, I2, and I3. Right? So if we look, how many nodes we have here? First of all, let's finish drawing this. We have a ground over here. And we have the resistors. R1 is 290 ohms. R2 is 325 ohms. And R3 is 100 ohms. All right. We know that the polarities will look something like this based on the assumed current direction. And now we can just start solving. Okay. We don't really need polarities in this case. لأنه we're not looking at the current, we're looking at voltage. We're just going to use KCL. We're looking at the node over here in the middle. This node, this is what we're looking at over here, right? Let's apply Kirchhoff's current law, KCL. KCL. What is KCL? KCL says that everything going in has to be everything going out. So what's going in? I1 and I3 are going in. So we know that I1 plus I3 are going in. And what is going out? I2. So they're going to have to be equal to I2. Again, you can either do it this way or you can do it the way where anything going in is positive and anything going out is negative. فمثلا يعني I1 it's plus I1. I2 is leaving, so it's minus I2. And I3 is going in, so it's plus I3. And this will be equal to 0. All right? And then you can rearrange the equation however way you like. زين? But for now, let's keep it this way so we can solve using this method, just so you see how it will look like. فالحين, we need to find out what I1 is, what I2 is, and what I3 are, using V equals IR. So I1 is equal to VR1 over R1, which is equal to VR1. We don't know what VR1 is, but we know that there is 20 volts coming from here, right? We know that we have 20 volts here. Okay? So we know that this is 20 volts. We are going to call this V0, V1, the node over here, not orange. شكلي بقدر أشيل هالorange, so let me just cover it in red. زين? So this is V1. we don't know what the voltage is. We're just going to name it V1. And we know that, so this is the red line at this node. Okay. And we called this our ground already. So we know that this is our ground. From here to here, this is all our ground. And this is V0, which we will call our ground, so it's equal to 0. And we have one more area, one more line, which is this line over here on the right side. And also this is already known. And we already know this voltage as well. Why? Because we have a source here. This source, if you notice, at the bottom side, it's also 0. So if you're going through it, it has to give 16 volts into this line. So this line here is going to be 16 volts as well. Okay? So we know that this line is 16 volts. We know that this purple line is 20 volts. And V1 is the only voltage that we don't have that we need to find. All right? We also have a node at the bottom. And then technically, this is also a node. But since it is connected to the ground, we already know that this voltage is equal to 0. Or we assumed it is also, we can make the assumption it's connected to the ground, so we know that it is going to be equal to 0. All right? And now we can start solving. Fair. I1, I2, I3. Let's start with I1. I1 is VR1, R1, which is equal to, what is VR1 equal to? From plus to minus. So it's going to be equal to 20 volts. And then let me put I1 a bit lower. Oops. عشان ما يصير خربطة. زين. This is 20 volts. زين. And here, let me remove this. This is 16 volts. I1 over here and I2 over here, the current, all right, or I3. Okay, this is the current. Fair. 20 volts is V1. So 20 volts minus, what do we have on the other side? V1, which we need to find out. So minus V1 divided by R1. What is R1? 290 ohms. Okay? 290 ohms. No need to put the unit. I2 is equal to VR2 over R2, which is equal to, again, we are going to look at it directly. R2 is the one in the middle. The plus, what's next to the plus? It's V1. So we're going to write V1 minus, what's at the bottom? 0, the ground. So it's 1V1 minus 0 over 290. Sorry, not over 290, over R2, the resistance R2. What's the resistance R2? 325 ohms. 325 ohms. In other words, this is equal to just V1 over 325. All right? Now the last one is I3, which is equal to VR3 over R3, which is equal to, again, we're going to look at VR3. VR3, now where's the plus sign? The plus sign is to the right side, okay? Keep that in mind. So the polarity is going from the right to the left. So what does that mean? It means it's 16 volts minus V1. All right? Again, I will repeat. هني الpolarity is going from plus to minus, لا? فit's 16 volts on the right side and minus V1. This is because we are assuming the current is in that direction. So it all depends on our assumption, okay? If we assume the opposite, it is fine, nothing wrong with it. But we need to make sure we're following the signs as we are assuming them. It's going from plus to minus, so we're going to do plus 16 minus V1 all over. What is our resistance? 100 ohms. And now we plug all of these into that equation over there. So we have I1, which is 20 volts. Let me just remove the volts, this sign. So 20 minus V1 over 290 minus, this is plus, this is going to be minus for I2, V1 over 325 plus 16 volts minus V1 over 100 is equal to 0. All right. We just used our KCL now to apply the nodal law or the node method, the node analysis. This is V1, V1, and V1. All right. So now all we have is V1. Here we could just how do we simplify this? We could just simplify it one by one. Another method that we used to do, I just remembered. So we do this, we just separate all of the parts. I think this is what you meant, Sajadla. And now we separate all the parts. So it's going to be over 290, then minus V1 over 325 plus 16 over 100 minus V1 over 100. And then equal to 0. Here, the calculator is your best friend. Let's group up the 20 over 290 plus 16 over 100. All right. Now we're going to get a value of 166 over 725. Okay, if we just do 20 and 190, all I did, this value came from grouping this, and then the constants. And we will do the exact same thing for the V1s. So it's going to be 1 over 290 or minus 1 over 290 minus 1 over 325 minus 1 over 100. And this is going to give us minus 623 over 3770 V1 is equal to 0. You can simply put these also in decimal form if that helps you guys. So I like to deal with fractions because it's a bit more accurate. But if it's easier for you guys, you can just convert this into decimal. But I'm going to solve it in the fraction way. So it's going to be 166 over 725 is equal to 623 over 37700 V1. So here V1 is going to be equal to 166 over 725, all divided by 623 over 3770. And V1 is going to be equal to, it is 166 divided by 725, all divided by 623 divided by 37700. And I get another fraction, which is going to be 13.86 volts. Okay, and that's it. And we found our V1. V1. So now that we found V1, doesn't matter what the question also wants from us. Let's see what it wants actually, so we can solve it as well. So the first thing the question asks for is the node voltage, which is V1. So we found this, all right? It's over here. That's the node voltage, V1. The current in IR1. Perfect. Let's look at the current in IR1. Current in IR1 is the current I1 that we called current I1. This is R1. So we need to find VR1 over R1. Then, so we are going to take this equation now that we already used earlier. And we already have V1 now. So this is going to be I1 is going to be equal to 20 minus 13.86 divided by 290. So it's equal to, put this in the calculator, 20 minus 290 divided by 2, okay. 0.021188, okay, amperes. Same thing again. They want the current in IR2. R2 is the one in the middle, this resistor. So we're going to take I2, this equation over here, and just use it. And then, so I2, we already found V1 is equal to V1, which is we found to be 13.86 divided by 325. So it's going to be equal to 13.86 divided by 325, 0.04265 ampere. And lastly, we're going to look at I3. I3, it is 16. I3 is equal to 16 minus V1, which is 13.86, divided by 100, which is equal to 16 minus 13.86 divided by 100, 0.214 milli, 0.0214 milliamps. All right? Amps, not milliamps. Obviously, we can convert them to milliamps. The question wants it in milliamps. All you're going to do is multiply each one by 10 to the power of 3 times 10 to the power of 3 times 10 to the power of 3 to find them in milliamps. Okay? Milliamps. Milliamps. Then that's it. That's it. We notice that none of our currents are negative. معناته the directions we assumed from the very beginning are correct. If we did get a negative current, just know that, okay, the current assumed is in the wrong direction. We will flip it. But it makes sense. All right? ليش it makes sense the currents are in the right direction in this case? We have two voltage sources. This will be always giving out current in that way. This will always be giving out current in this way. And then the only way they want to leave is going to be through the middle. So they're both going to go and reach the middle and then go back to their voltage sources. In the case if there is an additional voltage source here in the middle, or if there is another voltage source in the opposite direction, then you can assume that it will be difficult to instantly see where the direction is. But here from the very beginning, I saw and I knew that the current is going to be all in the right direction. But it doesn't really matter as long as you make your assumption. If it's negative, it means it's in the opposite direction. If it's positive, you are correct with your assumption. And that's it. And now we have finished all of electrical up to the midterm. شلون جبت 623 وين 623 بسم الله this one هاي حسبت 623 لأن minus 1 over 290 minus 1 over 325 minus 1 over 100. It gives me minus 623 over 3770. All I did was I grouped up these values. This minus this minus this. بس. Double check your calculation. يعني just to be clarify, if we're looking at it again here, what I did here, let me draw a line. Okay. What I did here was, let me move this to the other side, is minus 1 over 290 minus 1 over 325 minus 1 over 100. زين, this is all I did, and this will be all times V1 obviously يعني. زين. okay, صح زين. تمام, that's it. This is Nodal and we are done. Any questions? خلصنا المنهج بالكامل. This is it. المنهج up to the midterm at least. This is it. I kind of wanted to do superposition today as well. الحين I understand why teachers would like to teach sometimes things مال قبل الامتحان والطلاب يكرهونه, بس الحين حسيت فيهم ليش يبون يدرسون المعلومات. ولكن you guys are not going to use it in the exam, so I don't want to يعني أخرب عليكم بما معناه. أبغاكم تركزون على هالأشياء. If you guys have any specific questions, you can ask me now. Again, we will do a very quick recap about this. Nodal بشكل عام يعني. So Nodal, we are using something called KCL. KCL is basically when you are saying that it's Kirchhoff's current law, when you're saying all the current that is going into the node is equal to all the current that is exiting the node. Or another way of saying it is that all the current at this specific node will be equal to 0. All right. So basically, you're going to give a direction for the ones entering the node, a positive value, and then a negative one for the ones exiting, or the vice versa. It doesn't matter as long as you are being correct with your directions. And this is what you're going to apply for nodal. Then, so KCL, in this case, for example, the simple case, we have I1 going in, I2 and I3 going out. For I2 and I3, since they're going out, they're going to be on one side. I1 is going to be on the left side. I1, we know from V equal IR, we can find out that I is equal to V over R. Then, this, if we rearrange it, it's I is equal to V over R. Ohm's law, basic. Then, so I is equal to V over R. So I1 will be equal to VR1, also known as the voltage drop across R1, which is going to be equal to, how do we know what the voltage drop is? It is from the plus to the minus. So plus 7 minus V2. So plus 7, which is the V1, minus V2, divided by the resistance R1 in this case. So you divide it by 10. Same thing you will do for I2 and I3. You're going to look at the current direction, the polarity. You're going to look at the voltage. So for I2, for example, V2 over here, it's minus V0. ليش؟ لأن this is given as, we took it as the ground. All right. The ground, again, just a reminder, it's usually going to be assumed right under the negative side of the voltage source to simplify all your calculations. All right. Okay, and yeah, that's pretty much it. And then you will substitute everything into these equations, I1, I2, and I3 by using Ohm's law. Once you substitute, you're going to see that you have one unknown, all right, and you need to solve for it. If you have two nodes, in this case, we only have one node. If you have a second node over here, you might have simultaneous equations, but I haven't seen that at this level yet. After that, you're going to just solve for V2 for the node voltage itself. Once you solve for V2, like, or in this case, you're solving for V1, the nodal voltage, you can find out all the voltages across everywhere, or at the same time, I mean, all the currents across every component using, again, Ohm's law that we used early on over here, and we just substitute the values of V1, the nodal value inside. All right, and that's pretty much it. That's the whole calculation of nodal. هو مو سؤال مباشر عن اللي ناخذه، بس هل في شيء ما في voltage drop يعني حتى شنو؟ الكابسترات؟ دائما بيكون في voltage drop. ترى in reality حتى هو دائما بيكون في voltage drop. يعني انت قصدك الكاباسيتر، حتى الكاباسيتر بيكون فيه، يعني قصدك انزين what you mean is اذا الحين عندك هنا ريزستر، اذا كان في كاباسيتر ممكن يكون زيرو الفولتج دروب ماله، هذا اللي قصدك؟ انه ما في ابدا voltage drop ولا voltage gain ولا شيء؟ Is that what you mean? لا, that's not possible. There will always be a voltage drop. لأن تشوفوا extra knowledge زين بعدين بتقرون أكثر عنه. extra knowledge عندكم شيئين زيادة اللي هم الإندكتر and capacitor. Right? These two are also going to provide a different type of resistance to your circuit, also known as a imaginary part of the resistor. يعني remember you have a real part and imaginary. So these will provide, بعدين تدرسون وايد عن هالاشياء ان شاء الله في السمسترات الجايه خاصه في analog في AC circuit, but these will also provide a voltage drop. These also have an equivalent resistance value to it. Anything you put that is not a wire in real life, حتى الواير نفسه there is a little bit of resistance in it and there is voltage drop across a wire. And then voltage drop will always happen inside a circuit. It will always happen, voltage drop or gain. لأن there is always voltage going down and up. هو مثلا إنزين أنت تقول كأن عندنا bridge إنزين in real life عندنا bridge. okay زين we have a bridge or a hill. أنت الحين تبغى تقول لي can you reach the top of the bridge from the bottom without gaining any height or altitude or without losing any height when going down؟ شو ما كان الطريقة تقدر تروح فوق بدون ما تروح فوق؟ ما تقدر توصل فوق بالأصح without increasing the height of you relative to the ground. You cannot do that. This is the same exact idea. أو مثلا عندك river flowing وعندك شلال. زين، تقدر الحين تقول لي the river will not flow or يعني you can stop the flow of the river لو تشيل الشلال it will stop, بس you can move it without any forces or without any drop or gain of energy or gain of push or any gain of flow. ما تقدر. نفس الفكرة ويا current is basically like water flowing. زين، so if you guys want to try to understand a little bit more, إذا عندكم هني ماي أو rooftop يعني عندكم ماي basin كذي. All right, and this is filled with water and it is pouring out down. زين, and it is going into a river form كذي. من ناحية voltage, this is a voltage drop. All right, this is V1 and this is V2. If we are considering this to be our last point, this is V0. If we are considering this to be our last point وبعد ما بيطيح, we will consider this to be our ground. هاي الأرضية, هاي الأرض, هاي اللي حوالين هني كلها أرض. Okay, هاي كلها أرض. زين, so this river, the water is flowing in that direction. This flow will not exist if there was no voltage drop or if there is no voltage gain in the other direction. There is no possibility of flow of electricity, or in our case, we call it flow of current. It does not happen without any drop or gain. This is why there's always going to be drop or gain. The voltage source itself, which provides the voltage هني, it is providing a voltage gain. So there is always going to be voltage going either up or down throughout the circuit. And then the only time in our studies and while studying electricity where voltage is not changing is through a wire, because we are assuming that this wire is perfectly conducting. There is no resistance at all inside the wire. In real life حتى في الواير بيكون في slight voltage drop due to the resistance of the material of the wire. اللي تعلمناه في البداية, if you remember, resistivity and all of that, everything has a limit, a specific amount of resistance in it. I hope that answered the question. ايه هذا هو ال XL و omega, this is the imaginary one that you will see later on. فأي شيء تخليه هني, no matter what type of component you put here, it doesn't have to be necessarily a resistor. There will always be an لأن everything at the end of the day has some type of resistance to it, any type of شو اسمه component. Any questions about everything up to the midterm? Feel free to ask. Do you want me to look at a midterm question with you guys now, or أو تبوني أخليه حق session الجاي to do it all together from the beginning وتريحون شوية اليوم, يعني ليلة عيد حق بعض الناس, فكيفكم انتوا تشوفوا شو تبون and let me know. I'm going to be here anyways if you want to ask any question you might have. So this is the chance, I would say, look over your notes, look back, look at any point you want reclarification for, we can clarify now. This is your chance. And then it looks like no one wants anything. It's okay, take your time if you're still looking at your notes. I'm gonna still be around. But I'm gonna stop the recording for now.